I've never used this interface. I'm not familiar with it. That's the new Ubuntu. Oh, is that the modified GNOME? I never did like that. GNOME. I started out as a KDE person, and then I'm a XFCE guy now. Yeah.
Oh, this is a 16:10 display.
Mm-hmm.
Okay. Well, you can see the latency. I guess it's not.
Not too bad.
Not fun.
Yeah. Okay. So I guess we're ready. Is there things in particular you guys would like to talk about? Or what do you want to know about Linux? Because I can just like talk about some things, or I'd rather talk about things that you're mostly interested in. So
Do you think you could talk about like the password managers, so etc shadow?
I don't know anything about that. System admin stuff I don't spend a lot of time on because you're talking about like the password file.
Yeah.
Yeah. Yeah. I'm not exactly sure how all that works. Because I try to minimize the amount of time I spend doing system administration tasks by using a Linux distro that's kind of easy to use and install. So, like I've edited the password file in the past, but the way they hash the passwords, I don't really know much about that.
So I know how to navigate the file system
Yeah.
for the most part, but then there's a lot of tools within Bash that I don't really know. So I'd like to learn a lot more about Bash and what bin/bash means versus just regular Bash.
Okay,
Like
well,
more introductory stuff.
well, we can talk about the file system a little bit, and maybe I'll answer some of your questions, and then if you have questions as we go through it, ask. I'm going to load my website. Okay. So I have a domain name, devlang.com, which, that's interesting. Are we online?
That's something I should have thought about.
Yeah, I just realized that. I think maybe we're not online.
Does this not even have Wi-Fi?
Peep? Is it Peep or WPA? Enterprise, yeah. That's where you got to do the Peep. Yeah. Okay.
Let's see if I can remember where it is.
Oh, there's a certificate you've got to get from ASU. Okay. That might be why my VPN doesn't work anymore, is the certificate.
I've done this so
I
many
can't
times.
find it.
Will it work?
Is it going? Okay. There we go. So anyway, if you go to my website domain, which is devlang.com, I was hosting this with a web hosting company that got purchased by GoDaddy, and so I don't have a hosting company anymore. Unless if I wanted to host it with GoDaddy, who would be happy to, but so anyway, it redirects to my ASU website. I have this document I wrote because I teach this course 220, and in that course we teach the students a little bit about Linux and Bash. And so in the document I've got a section that talks about the file system. Yeah. Let's go to page, it's chapter 5, so I want to go to page 22. Okay. There we go. Throughout the document I use star nix because star means everything, or 0 or more occurrences of, so that way we can refer to Linux, Unix, and GNU Linux all with the same notation. So that just means Linux, Unix, GNU, Linux, whatever. So the files are organized into a file system. So the file system's part of the kernel, and the kernel is what, at the lowest level is what manages the file system and the directories and the files and all of that. So the file system is a hierarchical structure in the sense that it's organized into, we can call them levels. And at the top level, you have what's called the root directory, and the root directory is denoted with a /. So when we talk about the path to a file, the path consists of, well, let's just create a sample directory. So suppose I have, actually I've got an example in the notes. I've got a diagram with an example. So there's an example file system that only has a few files. But root is at the top, and then in this example I've got a folder under root, or a directory called home, and then a user called fredf, and then Fred has some files and things like that. So if we want to specify a path to a particular file, let's suppose that file we want to specify a path name to. If we're doing a root, an absolute path would be we start at root, and then we would go to the home directory, and then we would go to the fredf directory. So every time we go to another directory, we separate these with a /. In Windows, they use a \, which is wrong. And so then we would go to the directory source, and then the directory, or the file that we're interested in, which is file 1. Or file 01.0. Okay. So this is called an absolute path because we start at root and we go all the way down to the location where the file's at. You can also specify what's called a relative path to files. So if this source happens to be my current working directory, and I want to access this file, like I want to do a file command that accesses this file, then if this is my current directory, to access that file, I would type the command that I want to type, and then source, src, and then a /, and then the name of the file. And that would be a relative path name, because the file that we're accessing is relative the location of the file that we're accessing is relative to where we happen to be within this directory tree structure. So then starting at the top, we have several directories which you'll find are common among various Linux distributions and Unix, and also in the Mac OS operating system as well. Let's see. Let's open a terminal window here if I can figure this out. What? Okay. Terminal is where, Brenda? Search for terminal. There we go. Okay. Dang it. There we go. Okay, so CD is change directory, and CD / changes my directory to the root directory. The prompt on this computer is set up so that it displays the directory name that's your current directory or your current working directory in the prompt name. So I don't know if I can zoom this up or not, but there's a tilde there. So when I logged in or opened the terminal window, I was in my home directory. And then I did a CD / and so now it's displaying a slash because now my current working directory is the root directory. ls displays the files in the directory. ls-l does what's called a long listing. And so you can see there's these various directories that you mentioned, like bin and boot and CD-ROM and so on. Some of these I know what they do, so but not all of them. And I've got a list in the document starting at the beginning of chapter 5. Okay. So I've got a section here titled Common Directories in Linux, and so /bin in Linux terminology or Unix terminology, executable program files are called binaries. And so bin contains binaries for various commands. So if we go to bin, we can do an ls direct command. So if I do cd bin, that's a relative path name because it doesn't start with /. And so I'm going to make bin my current working directory. And then if I do an ls-l, it does a long listing, which scrolls off the screen. So in Unix, a vertical bar at the command like this represents what's called a pipe. And essentially what it does is it takes the output from the ls command and that becomes the input to the les command. And what ls does is it just displays the file that you send it as input one screen at a time so that you can page up and page down and view it. So if I pipe the output from ls through les, then this is just a list of the files that are in that bin directory. And there's one called bash. So that's where the bash binary lives. Let's see, CP. CP is the copy command. So that's a binary that lives in bin. What about, grep? Grep is a useful command. It stands for get regular expression, and you can use it to search a file for a string, a regular expression string. And ls is probably here. There's ls. So anyway, that bin directory just contains binaries that are yeah, never mind. That bin directory just contains binaries. Okay. And it'll be installed whenever you install whatever, or it'll be set up whenever you install the distro that you're using. In general, you don't need to mess with the bin directory, but if you're curious, you can go out there and look at the various binaries. And some of those you may not understand or see. There's a lot of these files I don't know what they do. Like for example, there's one called red, so if you want to try it out, just try it out. I hope that doesn't do anything bad. Okay. I don't know what red does. I can't get out of it either. There we go. What else? We have boot. Boot contains files that are used during the boot process. So if we go to cd/boot, that's an absolute path name because it starts with slash. So I'll go to the boot directory, and let's see, what do we have here? Yeah, in general, you don't need, once you install your distro, you don't really need to mess with these directories too much. It depends on how much. With Linux, you can spend a lot of time maintaining your operating system and doing things, or you can get a distro that's pretty easy to install and that it's pretty self-managed. I don't have the time to spend on a lot of system administration things, so I do a lot of things just using a distro that's pretty easy to install. So I'm not exactly sure about all that, but that's kind of beyond the scope of what I planned on doing anyway. Okay. Yeah, most of these directories that, like, if you go to root and you look at those various directories, most of those you really, unless if you're doing system administration things, most of those you don't really need to mess with most of the time. Now, when you're doing system administration type tasks, you will at times need to mess with those directories. But if you're just a user and you're just doing, writing code and compiling and building, it's not all that important. Alex, what about you? You said last time that you were starting to get into doing some software development at the command line. Do you guys know how to build programs at the command line?
I run with Vim.
Yeah.
Mm-hmm.
Yeah. I'll talk about it a little bit because it might be useful. I find it easier when I do developing software for my classes that I typically don't use an IDE because I don't really need all the features that the IDE provides. So I just use a text editor like Vim or Nano or something like that, and then I do my building and compiling at the command line.
So why would you use Nano? Why would someone choose to use Nano over Vim?
Some people like Vim. Some people don't. I have a chapter in here on Vim, which I was trying to find. It's a matter of preference. I don't know Vim very well because I would rather gouge my eyes out with infected hypodermic syringes found in the dumpster behind the plasma donation center until bloody pus oozes out of them than learn VI. I don't personally like VI, but some people like it. And Nano's just another editor. It doesn't have near the features that VI has. VI is actually a very nice editor. I just don't like the modal interface. It throws me off. Now I have a chapter that talks about building C and C++ programs. So you guys, if you're CS or CSE majors, now I know you're electrical engineering, but is everybody else computer science or computer systems engineering? So you may do some projects where you're expected to use write C or C++ code. So I have a section that talks about the GNU compilers, and maybe we'll talk about that. It's I'm trying to find it. Let me go to the table of contents. Hello. That's. There we go.
I've been using G++. Is that one of it?
Yes. Yeah. It's chapter 13. Chapter 13 is where I was trying to find. Yeah. I'll get there. Getting closer. There we go. GCC, when AT&T, which is where Unix was invented, developed, when AT&T started charging money, in the beginning they gave it away for free. They gave Unix away for free. And you could even get the source code. It was published in a book. And then AT&T started charging money for it. And Richard Stallman, who was a Unix user, decided to form a foundation to create an alternative version of Unix, or an alternative to Unix that would be free and open source. So he created the Free Software Foundation, and they have developed a kernel which is called Herd. Have any of you guys messed with Herd? So the GNU project. So he started what's called the GNU project, GNU. And GNU is an acronym for GNU's not Unix. So the philosophy was that this is an operating system that's not Unix, but it's going to look and run just like Unix in a way. So he developed, among other tools, they developed a suite of compiler software development tools, which is called GCC, which stands for the GNU Compiler Collection. And GCC doesn't actually mean the GNU C compiler. That's what I used to think it meant, but it doesn't. If you just let's search for GNU. So I'm just going to search for the GNU compiler collection. Oh, come on, really? There we go. So it includes front ends. What they mean by that is the program, the tool that reads the source code file and generates the intermediate code. So they have front ends for C, C++, Objective-C, which is a dying language, Fortran, Ada, Go, and D. And so the C and C++ compilers are the ones that I'm most familiar with using. If you install Ubuntu, it will install the C compiler. So the C compiler usually gets installed by default with whatever distro you install. But I know with Ubuntu, at least historically, it did not install the C++ compiler, so you would have to install that one separately. And how you do that's going to depend on your package manager. You can download the binaries for GNU from the GNU website, or they may already be probably in your package utility. So you'll get, when you install the C++ compiler, then you'll have the ability to compile both C and C++ code. So the command, let's create a little C++ program. I'll just do like the Hello World program. Yeah. That's the Hello World program. That's the Goodbye World program. It's my version of Hello World. Okay. So let's see if that compiles. Let's see if I can save it first. Let's call this goodbye.cpp. Okay. Actually, let me create a directory. To create a directory, I'm currently in, this is Barindu's computer, but I'm currently in my home directory. And so I'm actually going to create a subdirectory for my project. So to create a subdirectory or a directory, the command is mkdir, which stands for make directory. And then you just give it a name. And so I'm going to call my directory src for source. And then I'm going to move goodbye.cpp from where it's at to the source directory. So if I want to copy the file, I do cp. If I want to move the file, I do mv for move. So I'm going to take goodbye and move it to source. So both of those, by the way, goodbye.cpp and source, both of those are relative path names. So just the name of a directory or a file by itself as a relative is specified using a relative path. So now, if I do ls, the file's gone, and if I now make source my current directory, then there's my file. And then there's a lot of options you can use when you compile a program. So in the lab document that I have, I've discussed some of the more useful options. Okay. Darn it. Ugh. Sorry about that. I'm having finger problems. Oh, if you're going to compile from the command line, you use G++ to invoke the C compiler is G++. The C compiler is GCC. And C is technically not a subset of C++. There's a few differences between the languages, but for all practical purposes, C is pretty much a subset of C++. So you can compile C code using the C++ compiler. It has no problems with that. But this is a C++ source code file, so I can't compile it with GCC because GCC doesn't understand C++. So if I just want to compile this, you do G++ and then the name of the file. And then what that'll do is it compiles it. If I have syntax errors, they'll be displayed on my output window, and G++ isn't installed. Is it okay if I install it? Or will it take a while?
You're literally running in RAM, so.
Oh, okay. I'm not going to install it then. The G++ compiler is not installed. So let's just switch and do C.
I'm just curious, why can't you install it again?
I'm running off of a USB flash drive, a live distro.
Nothing is actually being saved to the.
It's not.
There is no hard drive in that computer, actually. Everything is running in RAM.
Yeah, so he's loaded like the whole operating system into RAM in essence, and so all of the files that I'm creating here, everything's being done in RAM. It's not actually being stored permanently on disk. So if I tried to install it, I might not have enough room in memory. Yeah. So let's just change my project into C code. Let's see if I can use VI. Oh, I do have a little chapter on VI, just the basics. So if you you probably know more about VI than I do, but I do have a chapter in here on VI and the basics, like moving lines around and copying and deleting. So if I'm going to change this to be a C program, I get rid of IO stream, and in C,
You should be able to install G++ actually.
really?
How big it is? Only 16 kilobytes.
Oh, okay.
That's not low.
My arrow keys are broken. Let's see.
I guess it probably has a gazillion packages that it requires. That's possible. There's no way that G++ can do it. Or
Okay. I got to get out of VI because the arrow keys aren't working. This is the most important thing to know about VI is how to get out. So you hit :Q and you're done. All right. Let me switch here because I couldn't get the arrow keys to work. So in C we would include standard IO.H. And then this becomes printf. And the indel becomes a new line. There we go. Now I've got a C program. Let me save that. Okay, so if you just do GCC file name, GCC is not installed.
GCC is 26 megabytes, but
Let's try it. If you've got a Unix distro, if you go to the command line, then to, did I say Unix? I meant Ubuntu. If you've got an Ubuntu distro, at the command line you can do sudo apt-get install and then the name of the package that you want to install. 73.4 megabytes of additional disk space will be used. This won't hurt anything if we do this, right? Or no?
sure we're not going to run out of memory.
Yeah.
Yeah, it should be fine. Yeah. Okay.
You've got 160
4 gigs of RAM total, 160.
160 megs free.
And how much is this?
It says it's,
Yeah,
well, it says an additional 74.
so you can probably get away with it,
Yeah.
but you won't be able to install much else.
Okay.
So.
Well, this may or may not work since we're running on a live distro, but I'm going to try to install the GCC compiler. It's thinking. There we go. Okay. So if you just do GCC file name, I'm not sure what that means. Well, anyway, I can't compile. If you just do GCC file name, it's going to compile your file and it's going to produce a binary. The executable file will be named a.out by default. So after this command runs, if I don't have any syntax errors, then this file will exist in my directory. And then to run your program, you would type ./a.out. So this will be the binary that gets produced, and then if you want to run your program, you type that command. Oh yeah, that's a good idea. Let's do that. Let me connect to general. I didn't think about that. I've been using general in the other weeks. Oh, I left off general. Okay, let me recreate my file. And since this is a C program, I'm going to change the file name extension to .c instead. There is a really cool website I found. I'm going to see if I can find it. Okay, there's my program. Now we can build it. Okay, I have a syntax error. Let me fix that. Oh, if you don't know, when you're at the terminal, you should be able to use up arrow to go up to the previous commands and down arrow to move throughout your commands. And while I'm on that subject, so you can use up arrow to go to the previous commands and down arrow. If you type history, it'll show you a list of the commands that you've typed. I think you can control how big your history list is, but currently I have 1,004 commands in my history list. Yeah. So if you suppose, for example, that I want to do this, and I don't want to type that command over again. I've already typed it once. That's command number 987. So I should be able to do a bang 987. Darn it. Oh, I must, what am I doing? Somehow I got into VI. Most important thing to know is how to get out of VI.
Is it just VI that you don't like, or regular Vim too?
I don't like the modal interface. I don't like switching between command mode and edit mode because it messes me up. So some editors, most editors, you're always in basically edit mode, and then you select menu items to do commands. With VI, you switch between command mode and edit mode, and I always start trying to type things when I'm in command mode, and it just messes me up. So I've never gotten used to it just because I've not used it enough. I badmouth it, but it's really a pretty good editor. So anyway, there's my, so when I do, let's see, I got to fix my syntax error. So I need to edit my program. So command number 1001 was my nano command. Let me see if I can redo that one. So if you do bang 1001, it'll re-execute that command, which opens my file, and now I can fix my syntax error. And then I can save this, and then I can get out of here. Oh, you asked about grep. If you do history, suppose there's a certain command you know that contains a certain string, like vi, then you can do history pipe. So we're going to send the output from the history command to be the input to this program, grep. And grep, in its simplest form, the syntax is grep and then a pattern and then a file to search. And so grep will search through that file for the pattern that you give it. And the pattern can be anything like a simple string, like that, or it can be more complicated because you can write a regular expression. grep stands for get regular expression. And regular expressions are something that would take quite a bit of time to go over, so I'm not planning on doing that, at least tonight. But that'll go through my history, and it'll display all of the entries where VI appears. Yeah. Dash. Oh, is that? I'm not sure. Let me check. I'm not familiar with all of the options to grep. Did I pass it? There it is, invert. Oh, okay, yeah, I didn't know that. Yeah, that's neat. So if we do that like this, then that'll display all the commands that don't contain VI. That's neat. Okay, let me try building again. And that command was number 1002, so I'll do a bang 1002. And now, because I didn't get any error messages displayed in my file folder directory, I now have a.out. And I can execute that by typing /a.out. Okay. And then your program runs. Now, you can pass a lot of options. For one thing, there's a reason why it's named a.out. I don't remember off the top of my head the story, but that's not necessarily the most descriptive name for your program. So if you want to give your binary file a name different than a.out, then when you compile, do a -o. And then following -o, you put the name of the file that you want the binary to be named. So I might choose to name this binary goodbye. And it'll build, and now in my directory there's a binary there called goodbye, and if I type that, it runs my program. You're supposed to type /. I don't remember the story why. Do you know, Brenda? It has something to do with security. Dot's your current directory. So that's a relative path name because it starts with a dot. And so it says go to the current directory and then look for the file goodbye and then run it. And there's a reason why you're supposed to do it that way as opposed to just typing it that way, but I don't remember. It has something to do with security. There's other options that you can pass to GCC, so I'll just highlight the important ones in the document because I give this document to my 220 students who are learning C and C++, and I expect them to learn how to do their development at the command line in Linux. -- version just prints out the version number of the compiler, so if you need to know what version of the compiler you're using, just do GCC -- version. Commands have options in Unix, and so options are parameters, sort of, that you can pass to the command when you run the command to tell it to operate in different ways. And in Unix, command options start with a dash. So you might have -v or -x. In the GNU world, they introduced, and traditionally they were just single characters. So you might have -v or -x or something like that. GNU project introduced these longer options which start with two dashes. And with the -- form of the option, usually you can write out a word. The idea is that -v is not very descriptive, but -- version is more descriptive. So it's easier sometimes to remember the longer commands or the longer options because they're more descriptive. Don't worry about -ANSI. -D. Oh, how many of you guys have you guys studied C in your courses? Okay, you're in C++, and you guys know C, and you are, yeah. So you'll learn C in CSE 240. So you'll take CSE 110 or 100 now, probably, and then you take a freshman who comes in normally would take 100 or 110 in the fall, and then they take 205, and then they take 240. So if you're in 205 now, then you could take 240 in the spring. If you're a computer systems engineering major, you'll learn C and CSE 220. And if you're an electrical engineering major, I don't know where you learn C. Do they teach a class there?
We have to take, we take C++.
Yeah.
And
Yeah, you
then-
take 100, I know, because I teach that course all the time.
Yeah, and then we're going to be taking,
I saw that. I know a student who's taken the Python class.
Python. They have a couple Python classes. They
Yeah.
have one that is a senior level class.
Yeah, it's like a 400 or 500 level.
I'm not,
Are you in that one?
I took it last semester.
Oh, okay.
I have to get linear algebra for it to take that.
Okay. Yeah. Yeah. And then they kind of assume you learn MATLAB, and you can program MATLAB, I guess.
Supposed to learn MATLAB at 342.
Is that it? What I'm telling you, like these options, this would apply if we were talking about the G++ compiler. So you could do G++ -- version. And let's just try that out. So GCC, unless if they've changed things, they do not update the software on general very often. So they're using version 4.8.5 of the C compiler, and they're using version 4.8.5 of the C++ compiler. Now, what version are we up to? GCC 9.2 was just released in August. So that's interesting. I would say general is a little bit behind. I don't think they update general unless if somebody requests it. So I know years ago they were using an older version of the C compiler, and at that time I requested them to install the newer version, which was 4.8.5 at that time, but that was several years ago. Anyway, so GCC, G++, command options that are primarily the ones you might use. G is important. -G tells the compiler to insert debugging information into the output, the binary file. And the GNU project has a debugger program which is called GDB. And so if you want to use GDB to debug your programs, then you have to compile with the -G option, because that will insert debugging information that GDB uses when you debug the code. So if I compile this code with -G, the binary looks the same as it always does, but now I can invoke the debugger by GDB, and I give it the name of the binary that I want to debug. Okay. And then now I'm in the debugger, and in the debugger you can start stepping through code. You just do an S command. Oh, you got to type start. Start starts the program up, and now I can, it says it's missing debugging information. Oh, yeah. I don't have everything installed here, I think, that I need. It's missing. GLibC is the GNU implementation of the C standard library, I think. And so it's missing the debug symbols for that. On your own PC, you should be able to do this the way I was showing you. Learning how to use a debugger is immensely helpful when you start programming, because your programs are all going to have bugs in them. It's impossible, to write a program without bugs, almost. And you can get by so far with print statements or cout statements, but even that has its limitations. And so I don't have time to go over the debugger tonight, but I'm just going to mention it. There is a chapter in the book that talks about how to use the GDB debugger. But I would suggest at some point you learn how to use a debugger. Now, your IDE that you use, whichever IDE you use when you write your C++ code, is probably going to have a built-in debugger. So you don't have to use GDB. GDB is an option, but most IDEs have a built-in debugger. And some of them, a lot of them, simply just make function calls to GDB. They use GDB as the debugger on the back end, and they just provide a GUI interface on the front end. Did you have a question?
Yeah, when I run with G++ and it does a compile and it gives me a bunch of error messages and
Yeah.
tells me where the
Mm-hmm.
error is, that is acting as a debugger, right?
No, that's just the compiler spitting out error messages. So that doesn't have anything to do with the debugger. That's the compiler which is producing those messages because you have syntax errors, I believe.
Yeah.
Yeah.
So like it'll say like it's expecting a semicolon.
Right, yeah. That's the compiler.
Okay, and then the debugger
Yeah.
will help you out more than that.
Right. So the process is you have your source code file. So suppose I have a source code file named foo.c. If I do GCC, and I want to name my binary foo instead of a.out, so I can do -o foo, and then I can type the name of the file that I want to build. This will produce a binary. Actually, the process is when you have a C file and you compile it, the first thing that happens before the compiler even starts reading the file is the C preprocessor runs. And the preprocessor, and this is true of C++ as well, the preprocessor is a program that reads the source code file, and you have lines that start with pound signs or hash marks. Those are preprocessor directives, like pound include. And the preprocessor is what reads those lines and deals with them. So pound include is not actually C code, or C++ code, it's preprocessor directive. This will spit out a file that is essentially, we'll call it foo.i. And then that file is, so the preprocessor runs, reads the foo.c and spits out foo.i. And foo.i contains the same source code as what's in foo.c, except all the pound includes have been deleted, and whatever header file was included is now included in foo.i. And the other thing the preprocessor does is strips out all the comments. So you can try this out. There's an option. I think I listed it here. I guess not. The GNU has, the compilers are incredibly complex. They have so many options. I think it's -e. Let's try this out. Oh, it's not foo, it's goodbye. There. So when I do -e, what that does is it tells the preprocessor to read the file, and then it sends the preprocessed file to standard out. And that's why it's scrolling on my screen. So it's sending the output to my screen. If I want to redirect the output to a file in Unix and Linux, you can use a greater than symbol. And a greater than pointing that direction, what this does is it says take the output from this program and send it to some file. So I can put a file name here. So instead of the output now going to the screen, it's going to go to the file. And then I can use less to look at that file, or you can open it in a text editor if you want. But what you'll see when you look at this is, remember I had pound include standard io.h at the top of my file? When you pound include a header file, the contents of that header file is inserted into the source code file that the compiler sees. So all of this stuff starting on line number 1 and all of that stuff, that's the contents of standard io.h. All of that. And then eventually we'll get to my code. Standard io.h is a big file. Let's try page down. And there's my code at the bottom. So all the comments would have been removed, and the preprocessor has now included the header files, and now this file will get passed off to the compiler. And then the compiler will compile that source code. That's one option. If you want to look at the assembly language, I know you guys were talking about the assembly language. If you want to look at the actual assembly language code that the compiler generates, there's another option. It's -S. This one right here. So this will cause the compiler to stop after it generates the assembly language code. So let's try that out. We'll do GCC -S goodbye.c, and I think it's going to send the output to the output window like it did before. Nope, it doesn't. In this case, it generates a file called goodbye.s. So in my directory, there's a file now there called goodbye.s. .s is the standard file name extension that's used in the Unix world for assembly language source code files. So
What was the extension?
.s. So it's this file right there. So in Unix and Linux and the Mac world, .s is an assembly language source code file. Yep. So let's do that. I'm going to feed it through less. Yeah, this will be what's happening now? Oh, I'm trying to pipe it. It needs to be this way. Okay, so that's the assembly language code that, and you can see it's very short because my program simply prints something and then returns from main, and that's it. So that's the resulting assembly language. Yes. Yeah. You, as an electrical engineer, will take CSE. You will take EEE 230 at some time, I believe. And the computer science and the computer systems engineering students take CSE 230. It's the same course. It's just cross-listed. And in that course, you'll learn some about assembly language programming.
Yeah, it's like this is assembly and it's a specific syntax.
Yeah. Yeah. There's not a standard assembly language. So the processor is designed to execute instructions, and those instructions are defined at the binary level in terms of ones and zeros, and you can get the technical manuals from Intel, and they'll tell you what all the instructions are and all that, the encoding and all that. I could create an assembly language myself that when I compile it, and you don't really compile assembly language code, you assemble it. So if I could create my own assembly language, and I could create my own assembler, and then I could make it so that that assembler generates the machine language code for whatever processor I'm targeting. Somebody else might create a different assembler with different syntax, but it does the same thing. It spits out the same machine language code. So this syntax is AT&T, sort of historical AT&T syntax. I think there's a way, actually this is, there's a way to specify, what is it? Oh, okay. Let's try that. So that's AT&T syntax, and then let's -M, and is it just Intel? Like that? Yeah. Let's try that. Nope, it didn't like that. Maybe no space. Oh, okay. There's a way to tell it to display the assembly in Intel syntax or AT&T syntax. Now, in 230, you'll actually learn MIPS assembly language, and MIPS has its own syntax. And so, but when you get to that course, a good way to learn assembly language, and I teach 230 a lot, so I tell the students this, a good way to learn assembly language is to write a C program or C++, assemble it like I just did using -s, and then study the code that the compiler generates. And that's a really good way to learn assembly language. So when you get to that course, remember that trick. Other options which may be useful, -C does a compile only. If you do GCC-C, it'll compile the file, but it won't link it. So after we go through this stage where the preprocessor generates its file and then the compiler generates the object code file, the object code file then is read by the linker, which is another program, and the linker takes the object code file that we produced when we compiled our program, and it links it with object code from the library to form the binary. So the linker is what produces the binary file. If you do GCC-C, it'll compile, but then it stops. So it doesn't link and doesn't produce the binary, it just compiles it. So if you just want to see if your code compiles and you're not interested in building the entire project, suppose I have 5 source code files that are part of my project. And I don't want to build the entire project because maybe it's not ready yet. But I just want to see if one of the files compiles, then you can do something like that. And then it'll compile that file and it'll produce the output file, which is called goodbye.o. .o is the file name extension that's used in the Unix world for an object code file. And object code is machine language instructions. So the compiler spits out machine language instructions, and then that goes in the .o file. So if you have a C project or a C++ project that has 5 source code files, when you build your project, it'll produce 5 .o files. And those 5 .o files then will be linked together by the linker together with object code from the library, and then it'll produce your binary that way. So -C is useful when you get into developing multi-source code file projects. Yes. Yeah. Yeah, I told you about man, right? So the man command, this is a pretty lengthy page. I read it. I read it from top to bottom over and over again. I like to turn on all warnings. So warnings are messages from the compiler that basically it tells you that you are doing something which may be wrong, but technically it will compile, it's syntactically correct. One of the most common mistakes that people make when programming in C and C++ is mixing up the assignment operator and the relational equality operator. The O file, let me save this first. So I have a .o file here, goodbye.o. Let me try loading that in VI. I don't know what's going to happen. That's a binary file. It's ones and zeros. So it's actually in a format. In Linux, object code files and binary files are stored in a particular format, which is known as ELF. I don't remember what ELF stands for, but it's a specification for how you organize the contents of the file. If you're really curious at digging apart a binary file, you can find the ELF specification. There's a PDF floating around on the internet one time that I found that explained things, but ELF, what it does is it defines the layout of an object code file or a binary file in terms of the ones and zeros. So an ELF file starts with .elf. So the first 4 bytes in the file should be 7F, 4F. Is that a dot? No, it starts with 7F, and then it has the word ELF. So if you look at my file, that thing that's being displayed right there is the 7F, and then ELF. Okay. You don't normally mess with binary files in a text editor, because text editors are designed to deal with text. But there are programs that you can get that allow you to screw around with binary files. And I don't know. Let me try that. GDB. I don't know if it'll take the .o or not, but oh, I didn't compile with -G. Yeah, normally I don't load a binary file or a object code file in GDB. It's a binary after you've done the linking. Usually you have to do start. And it's not liking that. It says permission denied. That's because it says permission denied because goodbye.o isn't executable. If you do ls-al, it displays the long listing. And in the long listing, that's funny. I'm looking at something completely different. There you go. In the long listing, remember we have these permission bits. And since there's no X right there, right here. Since there's no X right there, that file is not executable. Yes. Yes, you can do it on a.out because that's a binary.
What's the D stand for? I forgot.
D means directory.
Okay.
So in the permission bits, if you see a D in the first column, that tells you it's a directory.
Okay.
Yep.
And then read, write, and execute?
Read, write, execute. Yep. And the first 3 from the left are the group owner of the file. The next 3 are the user owner. And the next 3 represents others. So most, like Ubuntu, when you create your account in Ubuntu, it's going to create a group and it's going to add you to the group. So the group owner of this file is kburger2, and the user owner is also kburger2 because I happen to be in the kburger2 group. Yeah. And you can set the permission for each one. So if I wanted to make it X for the group, but not for others, I can do that. The way you set those bits is with change mode. So if I want to add the X bit, I do +X, and then I can give my file name. Okay. And now, if we do ls-al, notice that there's now an X bit right, see if I can get it, right there. You're still looking at the old one, right? No, that's the new one. Okay, yeah. There's an X right here, and then here's goodbye.o. And this computer's set up so that binaries are displayed in green. So now I know that's a binary. I still can't run it. because it's not a complete program. Gosh, there's just so much we could go over, but now Java is kind of similar. So if you're doing development in Java, let me see if General has the Java compiler installed. It does. I don't mind as long as you're kind of quiet, yeah. We're about done. So General has Java. So if you're doing Java development, again, I usually just use the text editor and I do my building and running at the command line. So in Java, if you have things set up correctly, the compiler command is GLibC. It stands for Java compiler. And in Java, when you compile it, you have a certain class which contains your main method, and I call that the main class. And so if my main class happens to be named main, and it's in a source code file named main.java, then I could compile that file or my project using this command. And this is going to produce an output binary which will be named main, and there won't be, well, I take that back. This will produce a class file. So in Java, when you write your code, you create a Java source code file. When you compile this, it spits out, if this is main.java, it'll spit out a file which is main.class, and it'll have a .class extension. .class is the Java equivalent of .o. So it's binary machine language in a way. It's virtual, it's the Java virtual machine version of a binary file. And then you can run this using the Java command. So Java, the way you execute a Java program is programs run in the Java virtual machine. So the code does not actually run directly on the hardware. The Java virtual machine simulates a computer which executes your code. But doing that is extremely slow. So what Java actually does is the virtual machine actually, on the fly, as it's reading your .class file and executing it, on the fly, it'll convert that code into native machine language instructions. And then those are executed directly on the hardware. If you just run a Java program, there used to be a command line option you could give it that tells it not to use they call that the just-in-time compiler. So the just-in-time compiler will convert your code on the fly into native machine language instructions, and that makes it run more quickly. There used to be an option where you could say disable the just-in-time compiler. And if you take a Java program and disable the just-in-time compiler and run it, it is incredibly slow. It's so slow that it's unusable. But Java's kind of similar. Instead of GCC to compile, you do JavaC, and to run, you just do Java, and then the name of your main class. Now, there's other tools that come with Java. So Java has a debugger as well. I think it's JavaDB, or is it JDB? Yeah, it's JDB, I guess. So JDB is like the Java equivalent of GDB. I don't know how to get out of this now. Okay, what else before we stop? You're getting close to time, I think, but what else do you want me to show you? I didn't go into regular expressions, though, but that's kind of lengthy. If you want, we can do that next week. Yes. Yeah. Regular expressions, they look like hell when you write them out, but if you understand the syntax, it makes sense. So, is that it? REG? Oh, there was something else I wanted to show you. Oh, cool. Yeah, I've not seen this before. So you can type in your expression. That's cool. So what if I do AB star X dot $? Then what happens?
Then it's parsing your
So it says it's going to match an A character, and then it's going to look for a B character, and the star here says 0 or more, so it's going to look for a single A, followed by 0 or more B's. The star means 0 or more, and so it applies to the thing that precedes it. So this in English says A followed by 0 or more B's, followed by the X character. Dot represents any character, one single character. So X followed by any character. And then normally $ means the end of the line of text that you're dealing with. So is that what it tells me here?
Yeah. If you go to flags at the top right and select multi-line, then it will parse it'll check your pattern against each line in the text section. You can change that text section
Oh, okay.
if you want to test it.
Oh, okay. Well, that's pretty neat. I'm going to have to play around with that. Yeah. So just to give you an example, you might do something like grep. Suppose you know that the file contains a string that starts with foo, and you want to find all occurrences of foo bar and foo baz and foo bar baz and anything that starts with foo. Then you could just do foo star. And then you give it the name of the file to search. And so it'll go through the file, and it would look for every occurrences of FOO followed by 0 or more characters. So it would print out anything that starts with foo, basically. Yeah. So we can go into regular expressions in a little bit more detail next week if you want, because they're pretty complicated. But once you learn the syntax, it's not too bad. But if you just look at a kind of a complex regular expression, it looks like very hard to understand. I get intimidated by them still too. Grep is immensely helpful. You'll use grep a lot if you do a lot of work at the terminal. And there's different versions of grep. I'm not sure of the different versions. There's one called egrep. So if you do man egrep, or just do man grep, there's one called grep, there's egrep, and then there's fgrep. And I don't remember the difference between them. Egrep is the same as grep dash capital E, so capital E is extended regular expression. Okay, so egrep allows you to represent extended regular expressions, whatever that means.
It basically means you can do more complex.
Yeah. It allows you to do patterns that aren't normal for grep. And then fgrep is the same as grep dash f, which is fixed string. Oh, okay. So fgrep, you just give it a string. It's not a regular expression. So you would just say something like fgrep. So if I want to find all occurrences of foo in a file, I could do something like that. That's faster than searching for a regular expression. Because when you search for a regular expressions require you to build a little parser, so to speak, that will go through the file, and it gets really complex. It's faster to search for a specific string than a regular expression. So you can think of fgrep as meaning fast grep.
I think you misread what it says. Fgrep will allow you to specify multiple different regular expressions, and they'll search for any of them.
Oh, is that it? Okay, maybe I'm wrong then. I didn't really read the description too closely. Let me come back here. It says fixed strings, interpret pattern as a list of fixed. Oh, okay, I see. So you can have more than one. Oh, okay. So they can still be regular expressions. Okay, I was confused. I thought,
For any in a list of regular.
I see. I was confused. What I said is still true. It's faster to search for a fixed string than it is a regular expression, but anyway. Time is it? 8:14. Date, we'll display the date and time. Okay, I think it's been around an hour, so I think I'll stop here. Before I do, though, any last questions? I really want to just help you with whatever questions you have. Some of them I can answer, some of them I can't, but so if you come next week, we'll talk about regular expressions if you want to, and then we can talk more about building at the command line. If you want me to show you how to use a debugger, we can talk about that. Whatever you want to do. So thanks for coming tonight. I'm sorry we don't have pizza. We have a budget problem, so. Thank you guys. I forgot your name.